Howdy, my name is Kifer with Hot Wheels Team 2. My teammates are Michael, Nathan, and Syed.
Hello, I am Syed Hamza, and I was on the mechanical sub-assembly team. And on the right side are a few of the lessons that we learned from the project, but I'm just going to go over a few of the more important ones. And the first one is that mass production does not lead to identical parts, and this is apparent in the picture on the left. That was one of the motor mounts we received from the original box, and as you can see, it's very defected. It's almost like falling apart. The second point is we were missing their tailbone, and that delayed a lot of the assembly of the total project as a whole, because it would hold the whole project together, and without it we couldn't work ahead. And the last important point is that planning ahead and like knowing that since we didn't have our tailbone, we could avoid everything that required it, and we could have worked around it. That would have saved us a lot of time in the long run, because it would have allowed us to work around it instead of waiting for it to come in.
Howdy, I'm Kifer. I'm on mechanical sub-assembly team with Syed. We spent a large amount of our time building the physical frame of the project. This included a large amount of initial measurements and cutting of the metal parts and integrating those with the 3D printed parts. We had trouble with some of the 3D printed parts, as I had mentioned before, such as defects in the prints. After overcoming these, we combined the physical frame with the H-bridge and the sled, as well as the CC3200 to form our completed robot.
Hello, I'm Michael from the control subassembly with Nathan, and these are our lessons we learned from the project. We learned the importance of consistency to make sure all things are working correctly, and we had to make sure that the wires from the launch pad to the H-bridge are correct, like how the green LED has to always connect to N1 and the yellow LED connects to N2. We also learned how to solder the wires to the power extensions so that the motors can reach the H-bridge. And then we also learned that implementation from software to hardware is long and hard, and that because we have to, in ENGR, write how strong the motors run, and that because of this, each motor runs also differently, and that the right side motors could be stronger than the left side, and vice versa. And we also learned how the wiring of the H-bridge works, and that how it distributes power to the motors and to the launch pad.
My name is Nathan Goynes, and I was part of the control sub-assembly. We had three main things to contribute when we were developing the project. First, we had to help assemble the sled and attach the motors, and there's a picture of us running the motor wires through the legs. Then we had to help edit the MATLAB and ENGR code used to drive the disaster robot and collect data. That took a while, and we still haven't really finished it, and we are not able to drive and collect data at the same time yet. We also worked on the wiring and connecting the H-bridge launchpad and batteries, which also took a really long time for us to hook all the wires up, get all the parts for the sled and everything, but we ended up getting it all done.
In conclusion, each team member should focus on the area they excel in, but also knows how the project functions overall. And having people with different engineering backgrounds allows for a deeper understanding of the project as a whole, which leads to different people having different inputs and different opinions on what's best for the project, and overall contribute to a bigger and more efficient project. This is a video of us reviewing this implementation. As you can see, we successfully run it in a straight line from the phone app, the DSTR app on the phone. I love America, I love MATLAB, I love ENGR, I love Coke, and I love engineering. God bless America.